Okay, what we're going to do now is actually solve a circuit using the node method, except we're going to apply, we're going to pick a different ground node every time through. I'm going to try to do this as quickly as possible, but we'll see the moral of the story should be that no matter what ground node we pick, we always end up getting a correct solution. Again, it's just going to be a different set of numbers, but they all end up meaning the same thing. So let me just draw out a circuit here. It won't be too complicated. Let's make this, I don't know, 5-volt source, and let's do a 1 kilo ohm resistor, and then let's do I don't know, 250 ohms, and then maybe 750 ohms. These are kind of clean numbers. Alright, so with the node method, what we need to do is pick a node to be the ground node. We then label all of our other nodes, and then we come up with our component equations and our Kcl equations for every node except for the ground node. Alright, oftentimes when you see a circuit, the one you pick to be the ground node ends up being the bottom one. That's just a convention oftentimes. It doesn't mean you have to do that, and we'll actually show that right here. But for right now, what I'm going to do for the first circuit we're making, and let me actually just make a copy of the circuit and save it for later so we can keep building on this. There, I'll dump you here for later. But yeah, let's call this node our ground node. I'm going to draw that little ground node line, and we're going to call this, E0. Let's call this E1 and E2. I don't see any other nodes present in this circuit. Then let's go ahead and label our currents through each component. So let's call this I1. Let's call this I2. I'm going to call this I3, and then this I4. Now each device's, the voltage across each component can then be expressed in terms of node voltages, right? So the voltage left to right across this 1 kilo ohm resistor, maybe if we had a V1, right, that would be E1 minus E2. Or the voltage across the 750 ohm resistor would be E2 minus E0. Now the ground node, the whole reason we even do this is to say, call one of the nodes 0. It's our reference. It doesn't mean it's like universally 0 or something. It just means it's 0 in the scope of the circuit as we're solving it right now. Okay, so we've labeled everything. First step is going to be, let's do our component equations, and we're going to jump around and express those component equations in terms of the node voltages and currents as we've defined them here. So what I'm going to do is come up with them. Actually, let's do them over here. So right here, the 5-volt source on the left side, that's saying 5 volts equals E1 minus E0, or 0 volts. All right, because E0 is our ground node, 0 volts. The 1 kilo ohm resistor, that is going to be saying E1 minus E2 over 1 kilo ohm equals I2. Our 250 ohm resistor, we can do the same thing. E2 minus, since E0 is 0, I'm not even going to write that here. E2, but well, I'll put it there for clarity. E2 minus 0 over 250 ohms equals I3. And then finally, for our 750 ohm resistor, it's going to be E2 minus 0 volts, I'll put 0 there, over 750 ohms equals I4. Now our Kcl equations, we're going to come up with one of those for each node that isn't the ground node. So over here for the E1 node, that'll be, let's call outward flowing current positive, I1 plus I2 equals 0. And then for E2, let's do negative I2 plus I3 plus I4 equals 0. Now if we hop around and look at this, we have E1, E2, I1, I2, I3, and I4. There are 6 unknowns. We have actually 1, 2, 3, 4, 5, 6 equations, so we should be able to solve this. And this is where you come in and start looking, and you're like, okay, immediately probably, well, this is just saying E1 is equal to 5, so that's good. So let's go through it then. So the first thing we can say is E1 equals 5 from that first equation. So that's good. We can just save that for later. Then what do we do? Well, at least in the way we set this one up, I2, I3, and I4 are all can be expressed as, functions of E1 and E2 only. And we know E1 is actually already a number, like 5. So we should be able to drop 5 in for E1, drop in the current equations right here for here, and then get an expression that's only in terms of E2. And then everything should just sort of domino out for us. So let's go ahead and do that. So I'm going to take this equation, drop in each one of these in, as well as this piece of information. So let's write that out. 5 volts minus E2. I'm gonna break up the denominators just for ease of use. 1 e to the 3 ohms over 1 e to the 3 ohms. And that's, oh, whoops, that's a minus. So let's do minus and then plus. All right, let's then do the next one. So that'll be E2 plus E2 over 250 ohms. Then it'll be plus E2 over 750 ohms equals 0. Fantastic. All right, now let's just multiply the whole. Let's multiply the whole thing by 3,000. What that's going to do is going to give us negative 15 volts. This will be plus 3 E2 plus 12 E2 plus 4 E2 equals 0. Let's lump these all together. That's 15, 19 E2 equals 15 volts. So we can say E2 equals 15 over 19 volts. Nice. Okay. We actually now have E1 and E2. Those are our two node voltages. Whoop, multimeter turning off. So we have those. We can now actually go back and figure out our currents as a result as well. So I1 we don't know yet because it's going to be based off of I2, but we can say I2 equals 5 minus, what's 50? Well, let me go get a math number in my head here. Python 5 minus, well, 15 over 19 is that. Okay, 5 minus. So that's going to be, and you could have kept these in fractions, I just don't want to. It's going to be what, 4.211 volts. Let me keep it at 3. So I2 equals 0.004211 amps. I1 will have to equal the negative of that from up here. Cool. So that'll be negative 0.004211 amps. I3 will equal, what's E2 again? E2 is 15/19, so that was, so let's do that. So 15 over 19 divided by 250, 0.00316. Let me, write that out so we're a little bit clearer on that. And then I4 will be the same number, 15 over 19 divided by 750. .00105. Okay, so we have I3 and I4, and I1 and I2. Okay. At this point, I might go back and just take a real quick look at like all of our numbers to make sure they make sense. So this is saying, E1 is 5 volts. That's good. E2 is going to be 15 over 19, which I believe we already, 0.789. So that's 0.789 volts. Just, just so we have a decimal in our head. Another important thing I usually do once I solve out a circuit is oftentimes make sure Kcl things make rough sense. So I know I2 should equal I3 plus I4 based on how I draw it, right? I2 flows in, I3 and I4 flow out. I2 equals 0.004211 or 4.211 milliamps. And these two actually do sum up to about that, right? Actually, almost, exactly on. I rounded just about right. So that's good. Okay, now what is this? What are these numbers all saying about the whole circuit? Well, again, it's saying what? The voltage source has 5 volts across it. The voltage across the 1 kilo ohm resistor, that equals what? That is E1 minus E2, or 5 volts minus 15 over 19. .210, 4.211. Cool. V across the 250 ohm resistor will equal 15 over 19 volts. Equals, I think we already figured that out, 0.789 volts. And then V over the 750 ohm resistor, since it's in parallel with the 250, is the same thing, 0.789 volts. And then we've already figured out the currents flowing through it as well. Cool. Let's solve it out a different way now. I'm going to jump down here to the next one. Let me make another copy. Okay, this time around, instead of making my ground node be the bottom one, let's just make it the top right and show that, at the end of the day, we get the same exact answers. So I'm going to put a ground node symbol right here. Let's label our node. So this is going to be E0. Let's call this E1. Might as well. Let's call this one E2 now. Now, it might feel weird that I'm doing this, but don't worry. This is all totally legitimate. Then let's label our currents. I'm going to call this one I1 again. Let's call this one I2. Let's call this I3. And let's call this I4. All right, now let's, and remember, E0 equals 0 volts, just for reference. So I'm going to immediately substitute that in while I'm coming up with my equations. So our component equations. So for the 5 volt source, it's different this time, right? It's going to be 5 volts equals E1 minus E2. For the 1 kilo ohm resistor, it will be E1 minus E0, or 0, over 1 kilo ohm equals I2. For the 250 ohm resistor, it'll be E0 minus E2 over 250 ohms equals I3. And then finally for the 750, it'll be E0 minus E2 over 750 ohms equals I4. Now our Kcl equations, we have to do a Kcl at each node that isn't the ground node. That means we don't use this upper right one anymore like we did previously, but we're going to use this one and, weirdly enough, this one. So our first one right here will be I1 plus I2 equals 0. Again, this is coming from the upper left, the E1 node. Then our E2 node, I have I1, I3, and I4 all flowing in. So that'll be, I don't know, let's do I1 plus I3 plus I4 equals 0. Now, if we go back and look at our equations, we can see I drew out the E0s. These are really 0. That was actually stupid of me to write it that way. Let me just put zeros here. So now it's consistent. So now how can we solve this? We can see that, all right, we have I3 and I4. We could drop those in, just get it in terms of E2. I1, unfortunately, doesn't have its own expression, but we could use this Kcl equation, which is saying I1 equals negative I2, to then make a negative version of this. So we could, taking this and this, say I2 equals negative E1 over 1 kilo ohm. Good. It's still kind of a bummer, right? Because we would like that. Oh yeah, but then we can use this one up here. And so that'll end up saying what? E1 equals 5 volts plus E2. Right, we can drop that in. So I2 equals negative 5 volts over 1 e to the 3 ohms minus E2 over 1 e to the 3 ohms. Okay, so now we have an expression for, what did we want? Oh, sorry, this was I1. Yeah, that's what we want. Yep. So I1, yeah, because that's equal to negative I2. Yep. So now we have an expression for I1 in terms of E2. I3 and I4 are also in terms of E2. We have this Kcl equation, so we can basically put this thing, this thing, this thing, and this thing together and then solve. So let's go ahead and do that. So it's going to be negative 5 volts over 1 e to the 3 ohms minus E2, 1 e to the 3 ohms. And I jump onto I3 minus E2 over 250 ohms, then minus E2 over 750 ohms equals 0. Cool. Again, you'll start seeing patterns as we do the math, like the same sort of things pop up. I don't like these denominators. I'm going to multiply the whole thing by 3,000 again. That's going to end up with, what, negative 15 volts minus 3E2 minus 12E2 minus 4E2 equals 0. Okay. Lump these together, that's negative 19E2 equals 15 volts. So E2 equals negative 15 over 19 volts. All right. And what do we know now? E1 equals 5 volts plus E2, right? Yep. Plus negative 15 over 19 volts equals what? Plus negative 15 over 19, 4.21. So these numbers should start seeming familiar, of course. It's negative, or I'm sorry, 4.211 volts. Fantastic. Now what we can do is then feed these into our current equations again. I2, for example, is just E1 over 1 kilo ohm. So I2 equals 4.211 volts over 1 kilo ohm, which equals 0.004211 amps. I1 is just the negative of that. Okay, I3 equals what? 0 minus E2 over 250 ohms, so that'll be 0 minus negative 15 over 19, so that's plus 15 over 19 volts over 250 ohms. We already know the answer to this if you've been following along, but let's just do it out anyways. 15 over 19 divided by 250. 0.00 3, what was it again? I don't even know. 16. Let's do 16 amps. I4, same sort of deal. 0 minus negative 15 over 19, so plus 15 over 19 over 750 ohms equals 0.00105. Okay, so we got all of our currents right here and our two node voltages. In big picture, what is this saying again, right? The voltage across our 5 volt source, E1 minus E2, should equal what? 4.211 volts minus negative 15 over 19. If you do this math out, it ends up being 5 volts. Awesome. The voltage across the 1 kilo ohm resistor, that's going to be E1 minus 0. So what is E1? E1 is 4.211, so V 1 kilo ohm. Going left to right was 4.211 volts. Voltage across the 250 ohm resistor is 0 minus E2, or 0 minus negative 15 over 19, or whatever. What is 15 over 19 again? 0.789. So that, sorry, we don't need a line there. And then same with the 750 ohm resistor. Cool. Now, if you look at all these numbers and compare them to these ones up here, same exact stuff popped out, right? Even though in between our node voltages had different numbers, but they're expressing the same things, right? And like, this is like, I think the weird thing maybe for this one is going to be, oh, we called this 0. All of a sudden, E2, the voltage down here is negative. But that makes sense, right? Because this voltage, whatever it is going to have a higher potential than whatever the voltage here is, right? Like current is flowing from here to here. We know this from solving it. Current will flow from a region of high potential energy to a region of low potential, and we're seeing that happen. All right, let's solve it one more way out. So we've grounded this node before. We grounded this node. Now let's ground the one remaining one. Let's call that E0. Let's call, I don't know, I'm feeling like this is E1. Let's call this E2. I'm going to label the currents the same way as before. Just it'll make comparison easier. I1, I2, I3, I4. And we know the drill here. So let's do the component equations. So that's going to be what? 0 minus E2 equals 5 volts. Excellent. The 1 kilo ohm is going to be 0 minus E1 over 1 kilo ohm equals I1. This one's going to be E1 minus E2 over 250 ohms equals I3. Then E1 minus E2 over 750 ohms equals I4. Kcl equations. So we have to do our Kcl at all non-ground nodes. So we can't do this one. We don't need to do that one. Let's do this one. So it'll be, let's do negative I2 plus I3 plus I4. And then let down here, we'll do the bottom one. E2 will be, they're all going in. Let's just do I1 plus I3 plus I4 equals 0. Okay, so what could we do here? I think the first easy thing to do would be maybe take this equation and then solve directly for E2. E2 equals negative 5 volts. That makes sense to me. Then we could use that E2 to substitute into each of the currents right here to get all of the relevant currents in terms of just E1, like the only unknown would be E1. And then we could drop that into this first Kcl equation right here. Yeah, that's going to work. And then we'll be able to solve out for just E1. So let's take this, this, and this thing and solve and see what we get, or substitute in and see what we get. So it'll be negative I2, so that's going to be E1. Yep. So E1 over 1 e to the 3 ohms plus I3. I'm going to break up the denominators again, so we're going to do plus E1 over 250 ohms minus negative 5, so plus 5 over 250 ohms. Then it's going to be plus I4, so plus E1 over 750 ohms minus E2, or minus 5, so plus 5 volts over 750 ohms equals 0. Again, I'm going to multiply the whole thing by 3,000 just to clean up the denominator. So that's going to be, and I'm going to move it over here a little bit, 3E1 plus 12E1 plus 60 volts plus 4E1 plus 20 volts equals 0. Let's lump the E1s together. Again, that's going to be 19E1. Move this, so equals negative 80 volts. So E1 should equal negative 80 volts over 19, which equals, let's go and solve that real quick, negative 4.2105, which, or negative, so negative 4.211, Yeah, volts. Good. And we know from before E2 equals negative 5 volts. So this is interesting. Let's go and solve our currents then. So I2 is going to equal negative E1. So I2 equals negative 4.211 divided by 1e to the 3 ohms equals 0.004211 amps. All right, this is looking familiar. I3 will equal E1 minus E2 over 250 ohms. So that'll be negative 4.211 volts minus negative 5 over 250 ohms. Just so you see me typing it out, negative minus 5, 0.00316 amps. Again, this is all looking familiar, and I4 will equal negative 4.211 volts plus 5 volts over 750 ohms equals the same stuff, pretty much. .00105 amps. Okay, so we have these. And again, the node voltages are weird now, right? Because E1 and E2 are negative 5. But that's okay. All it's saying, right, what? The voltage across the voltage source is 0, minus 5, or 5 volts, all right? The voltage across the 1 kilo ohm resistor, right? Let's write these out. So it'll be Vs equals 0 minus 5 equals 5 volts. V1 kilo ohm equals 0 minus E1, or 0 minus 4.211 volts equals 4.211 volts. We've seen that before. V250 ohm equals E1 minus E2, or negative 4.211 minus 5 equals, what's that end up being? We solved it before, 0.789, yeah. And then V, 750 ohms, same exact math. E1 minus E2, negative 4.211 minus 5. Cool. And these are exactly in line with what we got last time and the time before. So you can jump back through and compare them all.